So just to introduce the community, so Software Craftspeople community is a no-profit organization, and the aim of this community to connect like-minded software craftsmanship people. So whoever has this mindset, we connect those people together, and then the aim is to promote clean code and uh, best practices in the industry. So we actually use talks, conferences, and then workshops in order to promote this. And we encourage speakers across the world. We invite them, and we have regular sessions throughout the year in order to encourage these best practices. So about Incubate, Incubate is the organization which is the sponsor of this community. And Incubate also focuses on clean code and best practices. And that's why we are the founder of this community, Software Craftspeople India. So that's a bit about the community, about the speaker. So welcome Hemangi to the first session. so
Thank you.
b- so Hemangi is working with Epam System. She is a Python expert. She's also a developer and she's also a mentor. And today's topic is going to be about WSGI. So over to you, Hemangi. Yeah.
Sure. Let me share my screen. Let me know when you guys can see my screen.
Yeah, we can.
So, good afternoon, everyone. I hope you all are doing well. I'm Hemangi Karchalkar, and I'm a senior software developer at Epam Systems. Today, I am very excited to discuss an important topic in the scope of web development, WSGI, which stands for Web Server Gateway Interface. So, let's get started. On the screen, you'll see a diagram that reflects my early days at my first job, where my role primarily involved developing APIs by gathering client requirements. In this context, this is how I initially perceived Django's operation as follows. When a say I'm making a GET request with the endpoint /users from a browser or say Postman, Django follows a structured sequence. First, the incoming request is matched against the patterns which are defined in this file, urls.py file. If the requested endpoint is found there, the corresponding handler function, which is listed in views.py file, that is get all users, is invoked. This handler function is going to perform the logic and then return the response back to the browser. So, like, you guys might wonder, what led me to dive into WSGI? You see, when working with frameworks like Django or Flask, a lot of it is abstracted from us. These frameworks handle many operations on our behalf, like making the development smoother and faster. However, I encountered a major problem when I was challenged with a task of creating a web framework similar to Django or Flask from scratch. I was able to write the framework code, define the logic, but here I hit a major roadblock. And I found myself asking this question: how does my HTTP request actually gets translated into the Python code? This realization or this roadblock was the turning point that led me to explore what is this concept known as WSGI. So, faced with the challenge of understanding how this HTTP requests are routed in a web framework, I asked myself, how can I tackle this problem effectively? It dawned on me that I could leverage my experience with Django, a robust web framework which I had previously been using, already solves this routing and request handling challenges seamlessly. So instead of reinventing the wheel, I decided to delve deeper into this Django's internals. So where exactly and how exactly did I start diving into Django? One unconventional hint that came into my mind was deliberately writing incorrect code. By that, what I mean is when a code error occurs or some exception occurs in a programming language, what do we typically get? We get a stack trace. A stack trace, I thought I'll intentionally introduce some errors in my Django application, and this will lead to, this will give me a stack trace, which will point out where the error is coming from. And these stack trace will serve as invaluable breadcrumbs which will offer me insights into the inner workings of library. See, here we all are using Python, Django, or say whatever frameworks we are using, but how well do you know your source code? How well do you know your library, the way it is written? So if you take a look at my screen, you'll see a screenshot of the stack trace. And firstly, here in the Django, this is my views.py file. Here I intentionally raised an exception. And this is a snapshot of the stack trace. Two things that immediately caught my attention within the stack trace was a reference to this file, whiskey.py twice. From here on, I decided to explore further. So in my Studio Code editor, I took a closer look at the whiskey.py file. This first box is what was written in the whiskey.py file. I immediately, like this function, get whiskey application. This was a function that immediately stood out. I then performed a quick search within my code base to locate the definition of this function. And to my excitement, I discovered that this function, there is a call to something known as the whiskey handler. And upon further investigation, it was surprising that whiskey handler is not a function. In fact, it is a class which is implementing this callable. And I like when I found out these three snippets of code, what I did, I performed a Google search named whiskey handler. And the first link that appeared was titled PEP 333 Python web server gateway interface, which looked something like this. So if you take a closer look at the screenshot on the screen, you will notice several terms that have cropped up, like specification, interface, survey gateway side, application frameway side, and callable object. And also, like take a look, like we have this heading specification and there are certain lines below it. Okay, so first let's delve into what I mean by specification. In essence, a specification is a guideline or a set of rules that determine how something behaves or works. This diagram and this text box represents a refrigerator specification, an equipment that uses electricity to preserve food at cold temperature. So any machine that follows the above specification is known as a refrigerator. Like Whirlpool fridge or a LG fridge are some examples of refrigerators which are available in the market. Now, just like the example of refrigerator, where any machine that follows the refrigerator specification is classified as a refrigerator, we can draw a parallel to the document PEP 333 document. In PEP 333 document, there is a section titled specification with some lines below it, like the ones I mentioned. There is a title specification with some lines which are below it. So any software component that follows this specification is known as a whiskey server. And Mu Whiskey and Unicorn are some examples of whiskey servers that are available in the market. Now let's understand what we mean by the term interface. On the screen, you'll see a guy named Alan on the left side, and on the right side, you'll see a girl named Lana. Alan wants to impress Lana because he has got a thing for her. However, Alan has hit a roadblock because he knows only French, whereas Lana knows only English. Alan, being a male, will not leave a stone unturned to impress Lana. Therefore, he opts to enlist the help of his friend, Stan, who is proficient in both French and English. Thanks to the seamless communication facilitated by Stan, Lana and Alan are able to understand each other better and their love blossoms. To further illustrate the concept of interface, let's consider this diagram on the screen. It shows a mobile phone and a laptop connected to each other via USB cable. In this scenario, the USB cable acts as an interface between the mobile and the laptop. Despite mobile phone and the laptop having different operating systems and hardware, the USB cable provides a standard way to communicate and exchange data between them. Now, if we look at the dictionary meaning of interface, this is what it says: the place at which independent and often unrelated systems meet and act and communicate with each other, or it is the means by which interaction or communication is achieved. So now, since we have learned two terms, specification and interface, let's hop on to the other terms. server and gateway side. The server and the gateway side, it refers to Nginx or a web server. So what is a web server? A web server receives HTTP requests from clients, like it could be browser or Postman, and it is used to serve web pages. In this case, Nginx is one of the most commonly used examples of web server. Even Apache is one of them. An application or framework side, this is referred to your Python in my case. However, it could be a Java application or any other application, the language specific application. Now let's come to the third term, which says callable object. A callable object in Python is any object that can be called using the parenthesis. So a function is called using a parenthesis. So function is callable. In Python, we can also make a class callable by defining the underscore underscore call method. And this is what we saw like when I was going through the stack trace, and I saw a reference to this WSGI handler, which has implemented a call method. So in this case, they have made this class a callable. So as you can see, this is what we got. This is when I searched for WSGI.py file, I got a reference to this WSGI application, the definition of which is calling the WSGI handler class. And how come we are able to call, whenever we are calling this WSGI handler class, this dunder call method gets executed. Now, so what is WSGI exactly? It is a standard interface between web servers and Python web applications or frameworks to promote web application portability across a variety of web servers. So it says WSGI is a standard interface. So like we understood, interface is something that connects to unrelated or unresponsive systems together. So it will stand in between. It acts like a bridge. And anything that follows a WSGI specification becomes a WSGI server. So this box in between is a WSGI server, which is following the WSGI specifications. And why do we need it? Because the web server cannot, the web server interfaces the external world. It cannot understand a Python code. If I were to remove this block and simply serve this web application, remove the WSGI server, what will happen is it will render my Python code or a Java code like a text or HTML document, because it does not understand what the Python code or the language specific code that I have written. So earlier, as shown in the diagram, my understanding of how Django works was quite straightforward. When a user gets hits slash user's endpoint with a GET request, the URL is matched and the corresponding handler function in the views.py is called and the response is returned. But based on a previous exploration and understanding, we have discovered that there are many different things which are happening behind the hood. Here is a more comprehensive view of the process. First is the request initiation. The user initiates a request to the slash users endpoint from a browser or an API client like Postman. Then we have the web server interaction. The request first goes to a web server like Nginx, which manages the incoming traffic and forwards the request to the WSGI server. The WSGI server interaction, this is the next block. The WSGI server then passes the request, which it takes the incoming HTTP requests and then passes it to WSGI.py file. And here, the WSGI.py file, we have the function get WSGI application, which we saw in the previous slide, the get WSGI application. And from there, we have the middleware processing, where our incoming request is processed by the request middlewares, and they perform certain operations like logging or session management or whatever, some custom middleware that we have defined. And from there, we have this URL routing function, which is present in the get response. In this self dot get response method, the URL pattern is matched and the call to the views.py function is made, and the response before being written, again, it passes through a middleware, which is the response middleware. And then finally, the response is sent back to the browser. Now, I would like to explain some terms which are essential to understand how WSGI handles a request. So consider I have two tasks. My task one is to prepare coffee and task two is to clean my desk. And there is an actor named Hemangi, which is me. And we will assume that these tasks are running in a synchronous fashion. In this scenario, first I'll start by preparing coffee. And once the coffee is prepared, then I will proceed to clean my desk. This step-by-step approach where one task must be completed before the next task starts is similar to how synchronous operations work in programming languages. Now let's map the scenario shown in the diagram to the context of WSGI request handling. Here the two tasks become the two requests. The request one is preparing coffee, request two is cleaning my desk, and the actor becomes a worker thread. In this analogy, the request one, prepare coffee, is processed first. The worker thread starts preparing coffee. After finishing, it moves to the request to clean the desk. Okay. Now, in terms of synchronous communication, you might have heard the terms blocking and wait state. Now, let's delve into them. Say this scenario, only one worker thread is present and two tasks are there, like I explained before. Firstly, I am preparing a coffee, or the worker thread is preparing coffee. While I'm doing this, isn't the task two blocked because there is no one else to take the request? So this is what we mean by blocking. If only one thread is there and the other task is getting blocked because of anything, like you're holding the resources, or maybe you are you don't have sufficient resources, so the other task gets blocked. This is what is meant by blocking. And thread one, and which is the blocking thread? Thread one is the one, worker thread one is the one which is blocking other tasks. And wait state, the task two is, or the request two is known as, it is in a wait state. Now, instead of just one actor, let's consider there are two actors. Like I have this, I like to make my sister work for me. So I'll include my sister and I'll prepare the coffee and I'll ask my sister to clean my desk. So you might wonder, while I am preparing coffee, my sister is preparing, like cleaning my desk. So isn't this approach asynchronous in nature? So firstly, to understand or answer your question, let's understand the meaning of asynchronous. Imagine the same scenario, but with only one worker thread. I have these two tasks and the only person I have is me. So I'll start preparing coffee and cleaning my desk. So I start with the first task, that is prepare my coffee. While the water is boiling, instead of waiting, I'll hop on to the second task. Like the first test or the litmus test to identify if something is synchronous or asynchronous is, you have to understand, is that individual thread able to perform two operations, or is it waiting for the task to complete? Here, I being the individual thread, I am preparing a coffee, and instead of hopping onto the other task, like instead of waiting, I'm hopping onto the other task. It's not some another thread is coming and doing my work. I'm the one who is switching the context. So here, even though the water is boiling and I am hopping on to clean my desk, no other task is blocked. Hence, whenever there is a asynchronous code, you hear these terms non-blocking. And there is no mention of the wait state because I am just hopping to the other task and I'm finishing it. And now you may wonder, like this is exactly how ASCII servers operate. Asynchronous server gateway interface, which is an add-on to the web server gateway interface. So this is how they process the request asynchronously. Like if one request is under process, it won't wait until the request is completed. If there is a waiting time, it will simply hop on to the other to serve the other request. Now you might be curious to know how the worker thread, I being the worker, how am I able to access the code of this second task or the second request? To answer this question, I would like to present a diagram which many computer engineers or computer science students are likely familiar with. I think most of you have seen this diagram or we have drew this diagram. Threads of the same process share with other threads the code, data, and files. Here, the code of task 2 is converted into instructions, which even though our thread 1 is performing a task of one thread, the other thread or even the second thread can access the code because it belongs to a shared portion of the memory. Now returning to WSGI and synchronous execution. Why choose asynchronous methods over simply increasing the number of threads? Like in the previous example, even though it was synchronous nature, I mentioned I'm doing one work and I call my sister to do other work, but it is synchronous in nature because I being the thread, I am only attending to one task at a time. So why go for asynchronous thing? Why can't I simply increase the number of worker threads in my system? Instead of, if I have 10 tasks lined up, I can have 10 worker threads. So, and can we increase the number of worker threads? Yeah, obviously, I have shown we can increase the number of worker threads. And if so, then by how much? Okay, so this is an example of kitchen, and a kitchen provides resources for cooking. I think everybody will agree. It provides equipments for cooking and storing of food. Okay, and now if I increase the number of workers in the kitchen, what problems does it pose? We have like limited number of taps, limited number of chopping equipment, limited number of utensil, or you don't have the induction store. So there will be longer waiting time. So we don't entertain, like you won't allow like 30-40 people to enter your kitchen if the kitchen size is small. So what governs from this analogy, it is evident that the number of workers in the kitchen is determined by the specifications of the kitchen, like the kitchen size, the availability and equipment. If there's a small kitchen, we won't allow a lot of workers. If the kitchen is large, we'll allow. Don't think of small or short in terms of size, but in the terms of availability of resources in the kitchen. So now, similar to the worker threads and to the past analogy, the number of worker threads will be determined by the CPU, as the CPU is the one who is going to provide resources which are essential for execution of a program. The processing power is provided by the CPU, the registers, the diagram that I stored, the registers. If there are more worker threads, each thread will have its own stack registers and the registers which are used to store the intermediate context of a thread. So you won't be able to have uh, if you don't have memory, so the workers, you won't be able to create those workers. And there is a formula, like in G-Unicorn, while you're configuring WSGI, G-Unicorn is the WSGI server. We can mention the number of workers we want. Here it is 4. So, but on what basis am I keeping this number 4? This formula is given by 2 into number of CPU cores plus 1. If your CPU has 4 cores, then the optimal number of workers is 2 into 4, which is 8 plus 1, 9. So the max workers you can give is 9, but you can't exceed beyond that. So since we learned about WSGI, here is another way of defining a WSGI application. In this, earlier we saw an example wherein we defined the WSGI application by defining a class with a callable method, but we can simply define a function. And this example, this application is a WSGI application. So it takes 2 parameters, environ and start response. So the environment is like a dictionary or a JSON object, which contains parameters of your request, incoming request. And the start response is a callable function. You see, we are calling this function, so it is a callable. And finally, basically, I would say is WSGI forms the core of Python applications, and it is used for providing and handling of requests and generating responses. So this is how the environment dictionary looks like. This is for a particular example. It contains information about connection, like is it a HTTP method or HTTPS or something else, and all the query strings and all the important data that you're passing. Okay, to sum it up, WSGI follows a request response cycle. You send a request, you get a response, and the connection is terminated. And what are the advantages? Like we have an advancement over WSGI, which is known as ASCII, Asynchronous Server Gateway Interface. So why did we need this advancement? Because one worker thread cannot handle multiple threads. Like I being the worker thread, I can do only one task at a time. After finishing it, I can hop onto the other task, but I cannot leave my task between. And thirdly, the incoming request cannot be streamed. By that, what I mean is streaming is your request, you're breaking it down into small chunks of bytes and then giving it to the server. Since this is not a continuous connection and this protocol HTTP works over TCP IP, so you're sending a request. Once you get a response, your connection is terminated. So it doesn't know how you can stream and break down it into chunks and send. There has to be a persistent connection to send chunks every now and then. Example, there is a string and you're sending packets to your friend. This side you are there, this side your friend is there, and you're sending a big box, but you're sending it in small chunks. If the string itself is broken, you won't be able to send it, right? The string represents the connection. If the connection is terminated after you send it, you won't be able to send. This requires a persistent connection, which is not there. And also it does not support WSS, which means WebSocket protocol, WebSocket secure protocol. And this is a small understanding of this is WSGI, the upper one. You send a request, you get a response, and the connection is terminated. Whereas in a WebSocket connection, you send a request, you get a response, but this connection is persistent. It won't break. So say you have to develop a chat application. So any web framework who is following WSGI won't be able to do it. Hence, we had this advancement in Django 3. Django 3 has something known as WSGI.py. It also has WSGI.py and ASCII.py. So ASCII.py provides like persistent communication in the form of channels. The Django channels is something that is an advancement to look into, and we can develop chat applications using Django 3 and so on, where they have provided support for ASCII.py. Thank you.
Awesome. Thanks a lot, Hemangi. So we are open for questions now. Anyone has any questions?
I had two. First one is a small one. And yeah, thanks a lot for doing this, Hemangi. It was really insightful and loved your examples as well. So on the number of workers, the formula that you mentioned, 2x the number of cores plus 1. Number of cores makes sense because most Intel cores provide 2 threads, I guess, for 1 core. But what's the reasoning behind the plus 1? Is it like for redundancy, or uh, do you know if there's any particular reason for having that plus 1 there?
Okay. So this is something some researchers have done, and they have published some research papers. So honestly, I really don't have idea about it, but I'll definitely look into it.
Okay, cool. And another one is like in the wild, where have you seen WSGI is getting implemented, or if you have like a common use case, like if this is your ask, you should go with WSGI. If you have any examples of those.
Okay, anything, see, wait, I'll give you one example. Just a second. Where is that slide? I think some slides are getting skipped. Anyway, just give this. Your web server does not, I don't know, maybe I'm skipping some slides. So. Okay, yeah. If you look at this diagram, your web server only understands HTTP. It does not understand Python code. So you'll need something, even if you try rendering, and web server is can be used to render your static files. So your HTML, CSS, JavaScript files can be rendered by the web server, but it does not understand any language. So we in our Django application, there is a file which is WSGI compatible file known as WSGI.py file, which has this content. So if you don't understand Python and this understands HTTP, so there has to be some mediator that is going to translate it to it. Just like this is my phone, and say this is a type C charger and a type B. How will I connect? I'll have some mediator, right, to connect. I won't be able to connect them directly.
Yep.
So it is acting as a mediator. So if I remove this server, WSGI server, what will happen? Your entire Python code, say you're writing print statement and all. I think most of us have, say you enter some websites. Most of the times it has happened with IRCTC. It either runs into exception, or sometimes a Java code pops up as a on the screen instead of that. So what is happening is there in between WSGI server is not working. The Java code or say PHP code, sometimes it has happened when you hit a website, instead of showing the contents, you will see the code base, the exactly the Python code or say Java specific code or PHP code. In IRCTC, it is Java code. I've seen it many times. So it pops up because why? This server is not able to understand what is Python. This will treat it as like text file or HTML and it will start rendering it. So this is where WSGI is required. So in any Python application or any version of Django you use, you will see this WSGI.py file, which will act as an entry point of this. This server is going to call this WSGI.py file. That gunicorn command that I showed 2 into number of CPU cores plus 1,
Yeah.
that has a reference to this WSGI.py file. So it will call it.
Okay.
So that is the
So
use case. So anytime there is a routing and a web application you are developing, so that time you have to go from HTTP to a language specific code, be it Java, Python, or Node.js. You will have to have an WSGI server. Or otherwise, what will happen? Every time this is a standard. Why do we say this is a standard? If a web application follows the standard, like it takes a callable environment, which was a Python dictionary, and takes a start response. It follows this, like this is a standard. You will have to have a types of ports are there, right? There are standards. We can't make some port of our choice. If I make a port of my choice which is circular or say trapezoidal, I'll have to have my custom connector to it. So every time, do you want to write a custom web server or you want to follow the rules? Like these are the ports, I'll use the available ports in the market and get them connected. So it works like that.
yeah, makes sense. Thanks a lot.
I have one question regarding the security. In the slide that you have shown about Alan translating between the two people, uh, so can we trust the translator?
Yeah, because it is a see, it is a specification standard. It is a standard which has been accepted widely by the web servers and the Python web framework or the application servers. So it is a standard. So they have designed the protocol in a way that it is secure, right? Obviously, exploiters are going to exploit the system, but that's how systems generate, right? And evolve.
Uh, Thank you.
So just to relate it with anyone having Ruby on Rails experience, it is WSGI is similar to rack, what we have in Ruby on Rails. RACK rack.
So given that I have a traditional application, sorry, traditional HTTP request where WSGI is more suitable, right? And in the same application, I have a chat functionality also where ASGI is more suitable. So as far as I know that we use Daphne for SG and G unicorn like for
Correct.
WSGI, right? So
Correct.
if I want to use both of them, if I'm not wrong, this is where channels comes into picture, right? The thing that you were mentioning.
Correct.
So
Correct.
if I have an application that uses both of them, a traditional HTTP as well as the chat functionality, so how are all these configurations made in our Django or Flask or Fast API, whatever app that we are using?
Okay. So ASGI is a superset of WSGI. So anything that WSGI provides is going to be provided by ASGI. So you have to do the configuration in a proper manner. It's not like WSGI and ASCII are different things. ASCII is WSGI plus some extended functionality.
Yeah. So that's what I got confused. I was just looking at project structure of Django and that they both have both of them filed, like WSGI dot and ASGI,
Right.
both of them. So how does it even determine that where it has to go? Like at this point it has to go to ASCII and at this point it has to go to WSGI.
Okay, so if you use Django channels, in the functions, whenever the function is asynchronous, you have async keyword prepend to it. So anytime a request, like it will go to views.py, right? It is going to context switch. If you look at the definition of ASGI, the core body, it will check if it is a coroutine or a function. A coroutine is simply a function with the async like prefix to it. So it will just check if the function is prefixed with async. If it is prefixed, it will route it to ASGI. If it is not prefixed with, it will route it to WSGI.
Ah, okay, yep, makes sense.
Cool. Do we have any more questions? Cool. In that case, like, thanks a lot everyone for joining, and thank you, Hemangi, for giving us such a great session. So it was insightful for everyone, I think. Also for me, like I'm primarily a Rails application developer, but I was able to relate it and actually understand the minor things, why things actually exist, like why Nginx exists, why RAG exists. So great, insightful session. Cool. So we will be having this recording posted on our YouTube channel, and also we have upcoming session which is there on June 27, which is about distributed consensus by Jim. So don't miss that session. I will be posting the link to that also. So just I'm posting that in the chat for reference. Okay, I think Swati has already posted.
Also, thank you everyone
Thanks a
for
lot,
joining.
everyone.
And if you have any questions, you can reach out to me on LinkedIn or even on this chat.
Definitely. Thanks a lot.